Hey guys, welcome to the final video on Chapter 9. I have two goals for this video, guys. First off, I want you to understand what happens when something goes wrong with mitosis, and secondly, I want you guys to understand how cells can prevent problems with mitosis in the first place. So, the cell cycle, mitosis, what's going on? Okay, so basically the cell cycle is controlled by a series of on and off switches that occur at every single step along the way. These act as checks to make sure the cell is ready to go on to the next step. Think of it like the school system. You can't go to middle school until you have completed elementary. You can't go to high school until you've completed middle school. And you can't go on to college until you have completed high school. So there's a process that's going on. Now, in the cell, the same thing basically happens. However, there's a series of proteins involved in the process that I think it's important for you guys to know. First off, there's a protein called cyclin-dependent kinases. Now, from here on out, I'm going to refer to these as CDK or CDKs because it's a very simple way of saying it, because cyclin-dependent kinase is a very, very big word and not fun to say. Cyclin-dependent kinases basically act as police officers. They're the ones who are watching what's going on and kind of deciding if things are going to go one way or the other, if the cell's going to divide or not. Now, the cyclins are basically the signals. They're the ones, the proteins that come in and say, we should divide. So, when a protein's CDKs are hit by cyclins, it tells the cell to move to the next step. So, right here, let's say we have a cell in the G1 phase of the cell cycle. That cell is doing its thing, and eventually the number of cyclins, which are these little orange molecules here, they'll build up, get more and more of them, and eventually they will increase to the point of where there's enough cyclins to tell all the CDKs that, okay, it's time to go. Once there's enough cyclins, the CDKs say, all right, cool, time to move, and the cell divides. That's basically how the whole process works. So cyclins and CDKs work together to control the cell cycle. Now, there's a couple things to know here. First off, what happens when things break down? We've talked a lot about mitosis and what it is, but I haven't talked a lot about what can go wrong with mitosis. And as you probably can tell if you've read the slide already, it's cancer. When mitosis breaks down, cancer is the result. Now, the next video from TED Ed is going to explain to you how cancer works. So here's the video. I'm going to go ahead and cut that video into my video here so you can go ahead and get an idea about what cancer is.
We all start life as one single cell. Then that cell divides and we're two cells. Then 4, then 8. Cells form tissues, tissues form organs, organs form us. These cell divisions, by which we go from a single cell to 100 trillion cells, are called growth. And growth seems like a simple thing because when we think of it, we typically think of someone getting taller, or later in life, wider. But to cells, growth isn't simple. Cell division is an intricate chemical dance that's part individual, part community-driven. And in a neighborhood of 100 trillion cells, sometimes things go wrong. Maybe an individual cell's set of instructions, or DNA, gets a typo, what we call a mutation. Most of the time, the cell senses mistakes and shuts itself down, or the system detects a troublemaker and eliminates it. But enough mutations can bypass these fail-safes, driving the cell to divide recklessly. That one rogue cell becomes 2, then 4, then 8. At every stage, the incorrect instructions are passed along to the cell's offspring. Weeks, months, or years after that one rogue cell transformed, you might see your doctor about a lump in your breast. Difficulty going to the bathroom could reveal a problem in your intestine, prostate, or bladder. Or A routine blood test might count too many white cells or elevated liver enzymes. Your doctor delivers the bad news. It's cancer. From here, your strategy will depend on where the cancer is and how far it's progressed. If the tumor is slow growing and in one place, surgery might be all you need, if anything. If the tumor is fast growing or invading nearby tissue, your doctor might recommend radiation or surgery followed by radiation. If the cancer has spread, or if it's inherently everywhere like a leukemia, your doctor will most likely recommend chemotherapy, or a combination of radiation and chemo. Radiation and most forms of chemo work by physically shredding the cell's DNA, or disrupting the copying machinery. But neither radiation nor chemotherapeutic drugs target only cancer cells. Radiation hits whatever you point it at, and your bloodstream carries chemotherapeutics all over your body. So what happens when different cells get hit? Let's look at a healthy liver cell, a healthy hair cell, and a cancerous cell. The healthy liver cell divides only when it's stressed. The healthy hair cell divides frequently, and the cancer cell divides even more frequently and recklessly. When you take a chemotherapeutic drug, it will hit all of these cells. And remember that the drugs work typically by disrupting cell division, so every time a cell divides, it opens itself up to attack. And that means that the more frequently a cell divides, the more likely the drug is to kill it. So remember that hair cell? It divides frequently and isn't a threat. And there are other frequently dividing cells in your body like skin cells, gut cells, and blood cells. So the list of unpleasant side effects of cancer treatment parallels these tissue types: hair loss, skin rashes, nausea, vomiting, fatigue, weight loss, and pain. That makes sense because these are the cells that get hit the hardest. So in the end, it's all about growth. Cancer hijacks cells' natural division machinery and forces them to put the pedal to the metal, growing rapidly and recklessly. But using chemotherapeutic drugs, we take advantage of that aggressiveness, and we turn cancer's main strength into a weakness.
Okay, so the video should have given you a general idea how cancer works and some of the ways people try to treat cancer. Now, there's a few more things you want to know about cancer before I move on. First off, cancer is really a result of what are called mutations. Mutations are just problems that can occur with the DNA. So if I have myself a chromosome right here, and the chromosome is being copied, so during that S phase, it's being copied. Now let's say something goes wrong. Now normally you would get two identical chromosomes that would look kind of like this inside the sister chromatids right here. Now a mutation is when something goes wrong. So say now all of a sudden you have one that's the normal strand, but one strand is a little bit funky. And that new strand is a problem. It's a break in the DNA. It's an error in the DNA. We will go into a lot more detail about what this is in chapter 12. But for now, you just need to know that there's a problem with the replication and all hell breaks loose. This is what causes cancer. Mutations, random errors in mitosis lead to cancer, and mutations are basically their cause. Now, carcinogens are a fancy term here because when it comes to cancer, because normally there are mutations that happen just because of bad luck, but there are ways to create mutations if you want to get cancer quicker. And the ways you can do that are with carcinogens. Carcinogens are chemicals that damage DNA and cause mutations. A really good example of a carcinogen is tobacco. Tobacco causes mutations. This is why people who smoke have a really high chance of lung cancer, because smoking has carcinogens, which leads to mutations, which leads to cancer. So you don't really want to do things that lead to cancer because it might be bad for you. So smoking kills, and this is why. The second thing that can cause cancer is called viruses. The second thing outside of mutations that can cause cancer are viruses. Now, you've probably heard of a virus before, but you probably never knew they could actually create cancer. There's a good example. There's a virus called the human papillomavirus, and when you get infected with this virus, your chances of getting cancer skyrocket. And you're going to learn later on the reason for that is because viruses actually change your DNA. They go in and rewire your DNA to be beneficial to them, to be good for them. And that's what viruses do. So some viruses, because they change the DNA, can lead to cancer. Now, your body has ways of preventing cancer, and we call that apoptosis. Apoptosis is when your cell commits suicide. And if your cell thinks there's something wrong, it's going to kill itself, and that way the body doesn't get cancer and you die. So sometimes, obviously, cancer cells don't always go under apoptosis. So my meme here says, cancer cells, why you no undergo apoptosis? The reason is because there's a mutation in the cell, mutation in the DNA that prevents apoptosis. So if you have a mutation that damages the part of the cell that's programmed for apoptosis, guess what? You are not going to, the cell's not going to commit suicide, and you're going to get cancer. Now, there's one more part of this chapter I wanted to cover, and it's the idea of stem cells. And I am not going to do stem cells enough credit here because this is the part of biology that, boy, if you want to change the world, this is where you're going to do it. Stem cells are cells that can become any type of cell. So these are cells that can undergo mitosis and become whatever they want. So let's say Mr. Russell has a heart attack one day. And my poor heart, I'll draw a little heart here, it's very crude, and my poor heart dies. No heart. Well, what scientists are working on is they're finding ways to create stem cells that actually will allow me to regrow a brand new heart. That's another terrible arrow. I apologize. So what stem cells are is they are cells that can become any kind of cells. Now they're kind of like cancer cells because stem cells they grow very rapidly and they're constantly undergoing mitosis, but they are controlled. So what makes a stem cell different from a cancer cell is that a stem cell will eventually stop dividing or will become a normal type of cell, whereas a cancer cell never stops dividing and eventually kills you. So that's basically all you have to know about this particular part. Thank you for paying attention, guys. This is the very last lesson from this chapter, and I hope you guys do well on the assessment.